All right, so let's take a look at our confidence interval, but our problem's going to be word problems. So there's something we've been working with, the formula for our interval, right? This is something we talk about already. So I'm going to use X crossbarred. X crossbarred, I know we talked about mu before. Remember, it's a Greek letter that looks like a mu. The mu is the average of the whole population. Now, X crossbar, that's the average of the sample. But it's still the average though. So it's just as a reminder, the mu is the average of the whole population. X crossbar, we call it the average of the sample. Okay, so we start with the average, and then we did a plus or a minus. That's actually how we got two answers. If we needed to do the lower value of our interval, we did minus, and if we wanted the higher value of our interval, we did plus. And then we did a C scored, but we call it alpha divided by 2. Now, before I continue, there's still another part. I have to multiply this by a fraction here. So, but before I continue, now last week I gave you this value. Let me remind you of a table that we talked about last week. Remember this table? We had it on our work from last week. So from now on, when I say according to our table, for a 90% interval, if we're looking for a 90% interval, I'm going to use the value 1.645. If I'm looking for a 95% interval, I'm going to use the number 1.96. And for 99%, I'm going to use the value 2.575. Those are my C-scores according to our tables. I gave you this table. It is on our notes from last week. So from now on, I'm going to say according to our table, and this is what I mean. All right, so let me come back to what we were working with. Okay, so here's our C value, but I have to multiply this by standard deviation. Sometimes we use the sigma, the Greek letter sigma for standard deviation. Sometimes we use the letter S. Now the sigma or the S is basically standard deviation. And then I have to divide this by the square root of n. And the number n represents how many values are there in my sample. How big is my sample? N is the number of values in my sample. All right, so let's take a look at here. Psychologists at a university compared the levels of alcohol assumption for males and female freshman students. Okay, so we're looking at college students, how much alcohol males and females freshman students have. Each student was asked to estimate the amount of alcohol, which is beer, wine, or liquid, they consume in a typical week. Summary statistic for 128 males and 183 females are provided in the table below. Okay, so I see some information about males. 128 males were interviewed. The mean is 16.72 and the standard deviation is 13.51. And then I see females. I see my information here for females. Okay, so I know my table here. So I see my information. Now, let's take a look at the question here below. For each gender, find a 95% confidence interval for mean weekly alcohol assumption. For males, a 95 confidence interval is, okay, so I know my formula. And then let me rewrite it up here. I know it's the average plus or minus my C value, and then I multiply this by a fraction. Again, I could have the letter sigma there divided by the square root of n, even though sometimes instead of sigma, we use the letter S. That stands for a standard deviation when we're dealing with a sample. Notice how I gave you guys information here. I have the mean there. I gave you X crossbar, and then I wrote an S for standard deviation. So you guys know where those values come from. So according to this, a 95% interval, let me take a look at males, because the first question says for males. So I'm just looking at males. The average for males was 16.72. 16.72 plus or minus my C value according to our table. Remember, I talk about a table. I gave you guys a table last week. So according to our table, a 95% interval is 1.96. Had to multiply this. My standard deviation for males was 13.51. 13.51. I have to divide this by the square root of 128. There were 128 males. So for the lower value of my confidence interval, I'm going to use the minus sign. For the higher value, I'm going to use the plus sign. And then I also see here, round to the nearest hundredth as necessary. Okay, so looking at the word hundredth, it sounds like the number 100. Ends on a TH, so I know it's a decimal. The number 100 is a number with 2 zeros. So that means my answer should have 2 decimal places. All right. So I'm going to use my calculator. In this case, I'm going to round my answer to 2 decimal places. So 16.72 minus 1.96 times 13.51 divided by the square root of 128. My lower value, let me change this to blue. So for my answer, my lower value will be 14.38. Again, I rounded to 2 decimal places. Feel free to pause this video, type in the numbers on your calculator. Make sure you get the same values that I do. Right, I went 16.72 minus 1.96 times 13.51 divided by the square root of 128. Press entered, and I rounded my answer to 2 decimal places. So my lower value is 14.38. Now let me get my higher value or my interval. So I'm going to go 16.72 plus 1.96 times 13.51 divided by the square root of 128. My answer, I'm going to round it to 2 decimal places. I'm going to call this 19.06. And that is it. So according to our sample, according to the 128 males that we interview, I am 95% confident. This is what we mean with the 95% confidence interval. I am sure 95%. I am 95% confident that a random person that I get from my sample will be in between 14.38 and 19.06. Okay, that's actually a big number for alcohol in a week, but that's according to our data. So, okay. Now let's take a look at the other question. It says for females. So I'm looking at females now. My information is just here. I remember my formula. So my average for females, in this case, the mean for females is 10.77. Plus or minus my 95% confidence C-score. I know according to our table, that's a 1.96 times the standard deviation for girls was 11.53. So I'm going to write 11.53 divided by the square root of 183. 183 is how many females we interviewed. What's my N? So matter of fact, I even see the notation on my table. Okay, again, for the lower value, I'm going to go 10.77 minus 1.96 times 11.53 divided by the square root of 183. And for the higher value, I'm going to use the plus side. In my case, my lower case, I see 9.099. Okay, so I have to round it to, let me just write this right here, 9.099. So reminder, this 9 pushes this 9 over. Do not call it 9.010. Do not call it that because you did not round up. You rounded way low because 9.010 is 9.01. Remember, when we're rounding, because this 9 is at the limit, I'm going to push this 9 over. So my value is 9.10. Now that makes more sense. Okay. My lower value is 9.10. Now my upper value, 10.77 plus 1.96 times 11.53 divided by the square root of 183. Round your answer to 2 decimal places. I'm going to get 12.44. All right, that was not bad. It was easy. Let's take a look at another question. According to scientists, the cockroach has had 300 million years to develop a resistance to destruction. Okay, first of all, there's a number, 300 million. Doesn't really have much to do with my information. It's just telling me that cockroaches they've had a lot of years to develop resistance to our destruction to them. So that 300 million years, even though it's a numbered, it is just telling me they've had a lot of time to practice. Okay, so in a study conducted by researchers, 5,000 roaches, the expected number in a roach-infested house, were released in a test kitchen. So we released 5,000 roaches just to see what would happen. 1 week later, the kitchen was fumigated and there were 15,342. Remember, we put in 5,000, but now there is 15,342. That means that they gain 10,342 roaches for the 1 week period. Wow. Okay. So more than double in a week. Now assume that none of the original roaches died during the 1 week period, and the standard deviation of X, the number of roaches produced per roach in a week period, is 1.4. Okay, so now this is important. My standard deviation is 1.4. So let me just write that. I'm going to write here, my S is 1.4. Remember, my S is my standard deviation, my sample. I can use a Greek letter, sigma, but I'm going to use S. Now use the number of roaches produced by the sample of 5,000. Okay, so that's my sample. Let me write my N is 5,000. To find a 90% confidence interval. Okay, so I do have a C value, a C-score of 90%. According to our table, remember the table from last week, for a 90% interval, I'm going to use the C-score of 1.645. Again, I'm using the table from last week. Interval for the mean number of roaches produced per week for each roach in a typical roach infested house. Okay, so it would be nice if I knew my average, right? Let me just write X crossbar. If I knew my average. Now, how many did it increase by? Okay, so that one thing I have to do for my average, I see that there was a gain of 10,342 roaches. But we started with 5,000. So I want to know how many did it gain per roach. So what I'm going to do for my average, I'm going to go 10,342 divided by 5,000. Okay, how much did we gain? 10,342 divided by how many did we start with? So how much was the gain per roach? That's basically what I want to see. My answer, according to my calculator, I get 2.0684. Usually, when I ask you guys for numbers, usually ask you to round it to 2 decimal places or round it to 3 decimal places. But this is not my answer. This is just the number that I came up with. This decimal is not my answer. This is just my average. So I'm not rounding anything just yet. I always say round the answered, not the work. So I'm rounding not the work. So I'm just going to use my formula. I remember my formula. I'm going to go, my average in this case is 2.0684. So I'm going to go 2.0684 plus or minus, according to my information here, my C-scored for a 90% interval is 1.645. Have to multiply this by a fraction. Top of the fraction, I put my standard deviation, which in this case is 1.4. And then I have to divide this by the square root of n. How many were in our sample? In this case, 5,000. Now, for this question, it doesn't say here, but on your homework, I'm going to ask you to round it to 3 decimal places. Okay, not that bad. Just type it on a calculator. 2.0684 minus 1.645 times 1.4 divided by the square root of 5,000. If you're struggling on how to type it on a calculator, remember during school hours, I'm just an email away. Do contact me and I can go over how to type it in on your calculator. But again, I didn't round anything. I'm gonna use the minus for my smallest value. And remember, my answer, I'm gonna round it to 3 decimal places. So I'm gonna say my lowest value is 2.036. Good. Now for my big value, my bigger value in my interval, I'm gonna go 2.0684 plus 1.645 times 1.4 divided by the square root of 500. I'm gonna round my answer to 3 decimal places, and I'm gonna get 2.101. I'm rounding the answer, not the work. Notice how in my work, I have a number that has 4 decimal places, and I didn't round it. I'm rounding the answer, not the work. I typed everything as it was. Okay, let's take a look at another question here. Due to the popularity for instant messaging and social networking, informal elements such as emoticons, like the symbol, like the 2 dots and the parentheses to represent a smile, abbreviations like LOL, right? I've seen IDK, and believe me, when I get a test or a homework and I get IDK, we know that stands for I don't know. I usually respond back with ICT. That means I can tell. Right? You don't have to tell me you don't know. I can tell. Okay, so going back on this. So abbreviations and symbols have worked their way into teenager school writing assignments. Survey interview 900 randomly selected teenagers. Okay, this is important. I see a number. We interview 900 people. So that's my sample, right? I'm gonna say my sample here is 900. Overall, 451 of the teenagers admitted using at least one informal element in school writing assignments. Okay, so let's take a look. What does this mean so far? 451 of our teenagers said yes. I use this type of writing out of 900. So this, I'm gonna say this is gonna give me my average. My average, let me call it X crossbar, is going to be 451 out of 900 teenagers. Right now, my calculator says 0.50111. Okay. I'm going to ask you here, like, doesn't say here in the notes, but on your homework, these type of questions, I'm going to ask you to round it to 3 decimal places. So to not be that off, I'm going to go on my work up to 5 decimal places. So that's why I stop at 50111. Okay. Now, based on the survey results, construct a 95% confidence interval. Okay, we should have a C value, a C scored, a C scored for a 95% confidence interval. According to our table from last week, our C score here is 1.96. And it says, give a practical interpretation of the interval. Okay, so I know I need my N, I need the X crossbar, I need my C scored, and it would be nice It would be nice if I knew my standard deviation, but I don't. Okay, I don't have a standard deviation here. So there is another way how to do this when we don't have one of these values. I don't have my standard deviation. We're gonna do this for our we're gonna call the P hat and the Q hat. I'm gonna give you guys that formula right here at the bottom. My P hat and my Q hat. Now, what does P hat and Q hat mean? P hat means the probability for a success. I'm looking at what's the probability that a student does use those symbols when they write. So I'm gonna say basically my average. I'm gonna say 0.5011. Now my Q hat is what's the probability that a student does not do that. What I'm gonna do is I'm gonna go 1 minus P hat. So 1 minus 0.5011, and I'm gonna call this 0.4989. So P is the probability that they do use it, so probability of success, and Q is the probability of failure, right? The probability that they don't use it. I know my N is still 900, my sample is 900, and I know my C-score of 95% is going to be 1.96. We're going to use a formula now. So formula for our interval is going to be P hat plus or minus our C-score times the square root. Oh, okay. So now here I have the square root. Inside the square root, I have a fraction. P hat times Q hat divided by N. Okay, so how is this going to look on our work here? I'm going to go 0.5011 plus or minus 1.96 times the square root, but inside the square root, there is a fraction. And again, if you need help how to type this in, let me know. TI-30X are great calculators. Those are easy to type. Now, inside the fraction, I'm going to go 0.5011 times 0.4989. That's the top of my fraction, right? P hat times Q hat, and then divided by by 900, by my N. Type this in. Like I said, if you need help how to type it in on your calculator, do let me know. Okay, let's see. If I use the minus sign, 0.5011 minus 1.96 times the square root of 0.5011 times 0.4989 divided by 900, according to my calculator. And again, feel free to pause this. Feel free to pause this video, type it in, make sure you get the same number that I do. I'm gonna round my answer to 3 decimal places. I'm gonna get 0.468. For the higher value of my confidence interval, so I'm gonna use the plus sign. I'm gonna get 0.534. Now people might be like, do I use this formula all the time? Every time I have a P hat and a Q hat? Now there's a sample size validity. So there's a thing that we do to make sure this is good information. I have to go N in order for us to be able to use it, I have to go N times P prime or P hat. So in this case, 900. So for a previous example, in order for me to be able to use this, I'm gonna go 900 or N times our P hat and my value. I'm just looking at my value has to be more or equal to 15. Not only my n times my p hat, I also have to go n times q hat has to be more or equal to 15. So n times p hat, n times q hat, both have to be greater or equal to 15. If that happens, if you guys tried in our previous example, it does work. Okay, so we're good to go. Now, our last sample for today, our last question says, a random sample of size 200 yield p hat of 0.10. Construct a 95% confidence interval for p. Okay, so let me check in here. Let me check if I can use my formula that I just came out with. Why the formula that I just gave you guys. I have to go n times p hat. So n, so 200 times 0.10. And this answer has to be greater than or equal to 15. According to my calculator, I get 20. So it's good. It's more or it's greater or equal to 15. So it worked. Then I check n times q hat. And this has to equal to greater than or less than 15. Okay, some of you might be, I only have p hat. I only see that p hat is 0.10. Well, I'm going to say you can get q hat easily. For q hat, I'm just going to go 1 times p hat. So I'm just going to go 1 minus p hat. So 1 minus 0.10. So my q hat is going to be 0.90. So is 200 times 0.90 more than 15? More or equal to 15? Yes. Okay. So remember, we do the sample size validity. So I go n times p hat. I go n times q hat. This is the times. They both have to be greater or equal to 15. If they both pass it, then I'm going to use my formula. I know my p hat is 0.10. So I'm just going to do 0.10 plus or minus. My c-score for a 95% interval, according to our table from last week, for a 95% interval, my c-score is 1.96. And then this I have to multiply by the square root of a fraction. Inside the fraction, I'm going to go 0.10 times 0.90. So I guess I have to go p hat times q hat, divide this by 200. One thing that you guys might struggle with is the typing of the fraction. But again, if you need help, do contact me. I can help you on that. Okay, so let me type this on my calculator. I'm going to round my answer to 2 decimal places. So my lower bound on my interval is going to be 0.06. My upper bound on my interval is going to be 0.14.